ಹಲೋ ಪ್ರಿಯ ವೀಕ್ಷಕರೇ, ಕರ್ನಾಟಕ SSLC ಆನ್ಲೈನ್ಗೆ ಸ್ವಾಗತ. ಸೊ ನಾವು ಹಿಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ರಿಯಲ್ ನಂಬರ್ ಸಂಬಂಧಪಟ್ಟಂಗೆ ಸಮ್ ಇಂಪಾರ್ಟೆಂಟ್ MCQ ಕ್ವಶನ್ಸ್ ನೋಡಿದ್ದೀವಿ. ಸೊ ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ ಇನ್ನೂ ಕೆಲವೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ MCQ ಕ್ವಶನ್ಸ್ ಅನ್ನು ಮಾಡೋಣ. ಆ್ಯಂಡ್ ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ದೀಸ್ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ ಇಫ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ idea or the concept behind these questions, you can solve the similar kind of questions in your exams. Okay, so try to understand. Okay, question number 5. Yes, see, so if HCF of two numbers is 12, okay, and product of those two numbers is 1500, then you need to find the LCM of A and B. Okay, so you can observe the two numbers are A and B. Okay, so they have given HCF, they have given the product of two numbers, and you need to find the LCM. So only thing is you need to understand the relation between these three things: LCM, HCF, and the product of two numbers. So we know the relation, okay, that HCF of two numbers, okay, into, okay, LCM of again same two numbers is equal to product of two numbers. Okay, this is the relation. Okay, so HCF of two numbers given 12, okay, LCM of two numbers you need to find, okay, and product of numbers is also given, which is 1500. Okay, so what I need to find, in find madbekana LCM find madbek hoda. Now it is multiplication, shift other side, it becomes a division. So 1500 divided by 12. Okay, fine. So you can see 1 plus 5 is 6. 6 is divisible by 3. 1 plus 2, 3. It is also divisible by 3. So you can go with 3, okay, or even you can go with the 12 table also. Okay, so I'll go with the 3 as it is very obvious. 3 times 4, 3 times 5, 20. Okay, then 2 to the 250. Okay, so 250 by 2 means it is 125. Ithara madboda. Okay, so the final answer for LCM of two numbers, okay, is equal to 125. 125. So here option is A. Okay, the correct option is A. Okay, so what you need to understand, this relation is very important. Okay, HCF into LCM is equal to the product of two given numbers. Okay, so this relation you need to understand. Okay, yes, next one. Question number 6. Which of the following are irrational whose sum and product are both rationals? Okay, so when you ಹೇಳ್ತಿದ್ದಾನೆ ಇಲ್ಲಿ rational numbers ಕೊಟ್ಟಿದ್ದಾನೆ, ಎರಡು rational numbers ಕೊಟ್ಟಿದ್ದಾನೆ separated by each comma. Okay, so when you add these irrational numbers, you should get rational, and when you multiply again you should get rational. So which is that option which gives after addition and product as a rational number? Okay, that you need to check. So I'll go with the first option. Okay, so first option you can see. So if I add these two numbers, okay, it is like root 2, okay, plus 3, okay, plus I'm adding the next irrational number, it is root 2 minus 3. Okay, see, this complete number is irrational because irrational plus rational is irrational. So I consider the first term as irrational. Similarly, the second term is also irrational. Okay, so I'm adding both the terms. So here plus 3 minus 3 get cancelled. Root 2 you'll get a 2 root 2. So again root 2 is irrational. Irrational into rational is going to be irrational. Okay, but we want the answer to be rational. Okay, so here we are getting irrational. It is irrational. Okay, similarly, so I need to check with the second option. Okay, if I get a rational in the first option itself, I will not go for checking other options. Okay, I can stop there itself, but I am getting irrational, I'll check for the next two options. Okay, B. So again I'll add root 2 plus root 3 plus root 2 minus root 3. So again plus root 3 minus root 3 get cancelled. Root 2 you'll get a 2 root 2. So again it is going to be irrational. Okay, I'll go with the third option. So it is 3 plus root 2 plus 3 minus root 2. Okay, so root 2 get cancelled. 3 plus 3, 6. Yes, 6 is a rational number. Why? Because you can express 6 in the form of a P by Q, where P and Q both are integers. 6 is a rational number. But with this condition we can't decide. We also need to see whether the product of these two numbers gives rational or not. If you get product also as rational, then your option is going to be C. Okay, so we'll check for product. So 3 plus root 2, product means I'll just put bracket 3 minus root 2. Okay, so it is like a plus b into a minus b. So a plus b into a minus b is a square minus b square. So a square, okay, minus b is root 2 square. Okay, so 3 square 9 minus root and square get cancelled, you get 2. So 9 minus 2, you'll get 7. So again 7 can also be written in the form of p by q. So as per the question, this is the, this option is the correct one, which gives the sum to be rational and product also to be rational. Okay, so the correct option is, option C. Correct option is option C. Okay. Okay, next one. Question number 7. Yes, if the HCF of 65 and 117, okay, is expressible in the form 65m minus 117, then the value of m is, okay, you need to find the value of m. Okay, see, first we need to find HCF of the given two numbers. Okay, so then that HCF value we can equate it to the given expression. Okay, so we'll find, okay, so we'll find the HCF of 65 and 117. Okay, so first you can write factors. 65 as a 13 into 5. Okay, prime factorization, because 13 is a prime number, 5 is also prime number. Then 117, so 117 you can find in the 13 table. So 13 into 9, 9 further you can write okay, as 3 into 3, no problem. Okay, so you can write 13 into 3 into 3. Now as per the HCF definition, we know there should be common factor. Okay, we need to find a common factor for both the numbers with the least degree. Okay, so if you observe, the common factor is only 13. We don't have any other factor common for both the numbers, so only 13 is common. So our HCF is going to be 13. HCF is going to be 13. Okay, now they are saying now this 13 should be, okay, HCF of those two numbers is 13, which can be expressed in the form of 65m minus 117. Okay, so I'll shift number to other side, and it is 13 plus 117 equal to 65m. So first I'll write m term, 65m equal to, if you add this you will get to 130. Okay, and m equal to, it is 130 by 65. So 65 times 1, 65 times 2 is 130. So I'll get m equal to 2. M equal to 2. Okay, this is how you need to solve. So the correct option is here 2. Okay, so you need to go with the options sometimes. Okay, if you observe the previous question, okay, so here we have done till option C, because in the option C only we got the correct answer, so we didn't check for option D. Okay, but if you don't get till option C the correct answer, then we can try even D also. Okay, so for MCQ, no need to solve all the questions. Okay, where you get the answer correctly, there only you can stop. Okay, so that way you can go with the options also. Okay, yes, here the m value is 2. Okay, next one. Yes, again important. The largest number which divides is 70 and 125, leaving remainders 5 and 8 respectively. Okay, see, I'll give you an example. You take 14, okay, and divide this by 3. Okay, 3 4s you'll get 12, remainder 2. Okay, now how can you, what changes you can do for 14 so that that number should be divisible by 3, or even this indicates, if you subtract, okay, if you subtract remainder from the dividend, the so called new dividend should be divisible by 3. Okay, so it means the remainder should be subtracted in dividend so that that number is divisible by the divisor. So here they are saying there is a number which divides 70 leaving behind 5, and the same number when divides 125, it gives remainder 8. Okay, so in order to convert the actual number which divides these two numbers, okay, you need to subtract the remainders from these two respectively. So the so called number will be divisible. Okay, so as I give an example, Okay, now second thing, you need to find the largest number. So largest number means, is it finding LCM or HCF? Okay, see, the number which divides these two means the number should be either less than or equal to the greatest value, isn't it? So how you find the HCF? Okay, see, one thing you remember, HCF will be always, HCF value will be always less than or equal to least number. Okay, least number, less than or equal to least number. Okay, now, so the largest number which divides these two number means that number should be less than 125. Okay, less than 125. Okay, so this indicates that we need to find HCF, because the number which divides these two means that number should be divisible by, I mean that number should be lesser than these two. Okay, so I'll go with the finding a HCF. Okay, so HCF of, okay, HCF of, okay, so the actual numbers are 70 minus its remainder, comma 125 minus its remainder is 8. Okay, so you'll get HCF of, okay, this is going to be 65 and this is going to be 117. So again you can find its prime factors 13 into 5, and for 117 it is 13 into, okay, 9. So you know the definition of selecting factors when considered HCF. So when you consider HCF, there should be only common factor with the least degree. Here least degree is 1, nothing but 13, nothing but 13. Okay, so 13 is a number which divides both the numbers. Okay, so you need to understand, I told you the HCF value will be always less than or equal to least value. So here least value is 70, isn't it? Between 70 and 125, the least value is 70, and your HCF value should be lesser than 70 or it can be equal to 70 also. Okay, so here the HCF is 30. Okay, so the option is, okay, A. And even you can think with respect to option, how? So they, as they're saying these two numbers are divisible by any one of the number from options, okay, with the remainder 5 and 8. So you can go with option A. 13 5 is 65, remainder 5, and 39 is 117. Okay, so 125 minus 117 is 8. So this is with respect to option A. So no need to check for all other options. Okay, so with the options also you can find. Okay, as far as MCQ concerned, okay, you can go with the options also, but subject to this is the steps you need to follow. Okay, so the correct answer is 13. Okay, next one. Yes, the least number that is divisible by all the numbers from 1 to 10 both inclusive is, okay. So again there is a number, okay, so there is a number, let me take x. Okay, this number is divisible by 1, okay, 2, 3, okay, 4, so on up to 10. So you need to understand inclusive means including. Okay, so you need to include even the lower value and the higher value, both you need to consider. Okay, it means this number should be divisible. Okay, this x number should be divisible by all these numbers including 1 and 10. That is the meaning of inclusive. Okay, now you think when this number is divisible by all these, okay, then this number should be more than these factors. Okay, so more than these factors means you need to find the LCM. Okay, because we know LCM will be always greater than or equal to greatest value. Okay, greatest or highest value, greatest value. Okay, as in HCF it is less than or equal to the lowest value. For LCM the value will be always greater than or equal to greatest value. Okay, so we came to know that the number which is divisible by all these factors should be more than the factors. So more than means you can find the LCM. Okay, now you need to find the LCM. Okay, so LCM of I need not to find all factors. Okay, the factors which are common I can take. Okay, so I can take 2, I can take 3, 4 means you can write 2 into 2. So already have covered the 2, no need to take again 4. Again 5, okay, 5 I can consider. 6 you can write 2 into 3, isn't it? So if a number is divisible by 6 means that number is also divisible by 2 and 3. So I have already taken 2 and 3. Okay, then 6 I have included 7. Okay, 7. Then 8 means you can write a 2 cube. Okay, 2 cube. So 2 I have already considered. Then 9 means 3 square. So already considered 3. 10 means 2 into 5. 2 into 5. Both are there. It means I need to find the LCM of these 4 numbers. Okay. So this is a number which is divisible by all these numbers, means you need to find the LCM of these 4 numbers. Okay. Now a very important point I am telling you. Whenever you find LCM of prime numbers, okay, these are prime numbers. Okay, in such case the LCM will be multiplication of number itself. So it is nothing but 2 into 3 into 5 into 7. Okay, so I'll go with first 2 into 5, 10, then 3 into 7 and 21. So it is going to be 210. Okay, so 210 is a number which is divisible by all these factors. You can check. But in the option, do you have 210? No. It means the number is actually higher than this. It means if 210 is divisible by all these factors, then its multiplication also divisible by all these factors again. So I'll just go with its next higher multiplication value. So if I multiply with it into 2, it is 420. Okay, 420 is not there. Okay, if I multiply with 3, it is 630. Okay, 630 is also not there. So the only option left is D, which is more than 630, isn't it? So till 630 we don't have any options. A, B is cancelled, so only the option is going to be option D. Okay, no need to check even. Okay, it means if 210 is multiplied with some factor, then you will get a 2520, which is divisible by all other numbers. Okay, so this is how you need to find. Okay, so this is also one of the important questions. So inclusive means you need to consider the least and highest value. Exclusive means you should not consider the least and highest. You should not consider. Okay, but inclusive you have to consider both lower and upper limit values. Okay, next. Yes, last question, very important. If sum of two numbers is 12, 15 and their HCF is 81, then the possible number of pairs of such numbers are. Okay, so the question ಸ್ವಲ್ಪ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಟ್ರೈ ಮಾಡ್ರಿ. ಓಕೆ, ಎರಡು ನಂಬರ್ ಅಂತ ಹೌದಾ? ಸೊ ಲೆಟ್ ಮಿ ಟೇಕ್ okay, so A and B are number 1 ಅನ್ಕೋರಿ. ಹೋಗ, so these both numbers have a common factor. HCF means common factor, which is 81. 81 is a common factor, but common along with the common factor they have some other factors. Let me take X and Y. Okay, so now I need to find the possible number of pairs of such numbers, means I need to find for X and Y the possible values of X and Y when after multiplying with 81 and after adding I should get 12, 15. Okay, so we try to simplify. So we'll write first as let two, okay, numbers, let two numbers are yes 81x and 81y. So you need to consider with the HCF value, because this factor is common. 81 is common for both the numbers, isn't it? Now, so what they told, sum of two numbers. So we have took two numbers as per the statement, and now sum means 81x plus 81y equal to, okay, 1215. Correct? Okay, now so you can take 81 common, it is x plus y equal to 1215. So now x plus y equal to 1215, okay, by 81. Now again you can go with the divisibility rule. Okay, so 8 plus 1 9, 1 plus 2 plus 1 plus 5 will be again 9. So both are sum, both the terms sum is 9, means it's divisible by 3. Okay, so I'll go, even it is divisible by 9, okay, but we'll go with the 3. Okay, so 3 2s are 6, 3 7s are, so 3 4s are 12, 1 is less than 3, 0, 3 5s are. Okay, next 3 9s are and 3 1, okay, 3 3s are, okay, 3 5s are. Okay, then so I'll go with 3 3, 3 4, 3 5. Okay, finally 3 1s are 3 15. Okay, so I'm getting x plus y, okay, x plus y, x plus y to be 15. Okay, I'm getting x plus y x plus y to be 15. Now you need to select a pair, okay, possible number of pairs of such numbers. Okay, now you need to select two numbers for x and y so that the sum should give 15. So you can go with the 1 comma 14. If you add, okay, you will get 15 as per this condition. You can go with the 2 comma 13. Okay, you can go with the 3 comma 12. Okay, you can go with 4 comma 11, 5 comma 10, 6 comma 9, okay, 7 comma 8. Okay, so like this you can go till 14 comma, okay, 14 comma 1, 14 comma 1. But here you need to consider only some numbers which forms the pair. Okay, the actual pair is going to is going to be 1 comma 14, 2 comma 13, 4 comma 11, okay, 7 comma 8. It means only there are 4 such possible number of pairs which satisfy the condition. Only 4 pairs. But now I ask you to students, why not we consider other pairs? What is the reason behind it? I can consider only the 4 pairs, 1 comma 14, 2 comma 13, 4 comma 11 and 7 comma 8. Why don't I consider other pairs? What is the reason? So I'm expecting answer from the student side. So if you have any idea, you can put your explanation in the comment section. Okay, so for this the correct answer is going to be 4. We have 4 combinations, okay, 4 pairs of such numbers which satisfy the condition. Okay, so I'll explain you in the next class why we consider only 4, but I'm expecting from student side also. Okay, however, if you put all these pairs, the sum is going to be, okay, the sum is going to be 15 itself, but you can't take all pairs. So for that you need to tell me why we can't take other possibilities. Okay, so this is an important session, and in next class we will discuss MCQ questions of next chapter. Probably we'll start with the pair of linear equations in 2 variables. Okay, so we are getting good response, and students are very happy. Okay, and keep supporting. So we will come with some more good videos, okay, and help you in getting scoring good marks. Okay, so in next spell we have planned to start with the even associated reason type of questions, and we'll also go with the previous year question papers. So we make students to prepare thoroughly for the exam point of view, and they can get good marks. Okay, so keep watching. Thank you.